Ladies and gentlemen, here we go for our quizzes for Chapter 9. So first quiz, questions 1 through 3. There's some values that are underlined, and we have to decide are they parameters or statistics. Statement number 1, 42% of today's 15-year-old girls will get pregnant in their teens. Okay, notice this is not talking about a sample in any way, shape, or form. So this is a parameter. This is an old parameter, by the way. The number is actually a little lower, quite a bit lower today, which is a good thing. All right, number 2, in 1993 survey, a 1993 survey conducted by the Richmond Times, 1 week before Election Day, asked voters which candidate for state's attorney general they would vote for. 37% of the respondents. Okay, so this is obviously coming from a sample. So 37% is a statistic. Okay. On Election Day, 41% voted for the Democrat. Okay, that is the parameter. That's the actual number that voted for that candidate. All right. Number 3, National Center for Health Statistics reports that the mean blah, 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 blah is, okay? Notice, again, this is not talking about from a sample. So 128 is a parameter. Standard deviation of 15, also parameter. All right, large company looks at records of 72 executives. So now we're talking about a sample. Okay, so that 126.07, that is a statistic. There you go. So these types of problems, hopefully they're very easy. It is very important though, because as we move forward, being able to decide a statistic versus a parameter determines what number goes where in your formula. So that's why it's important that you can get that right. All right, questions 4 through 7. Label each relative to others as large or small bias and as large or small variability. All right, so you can see these two have large variability, these two have small variability. These two have large bias, these two have small bias. So large bias, large variability. Right. Again, bias is it off the mark, right? The average data is low here, so it's off the mark low. And variability is, of course, the spread. Compared to the other graphs, this is more spread out than these two. All right, this one's on the mark. This is good stuff over here. Small bias, small variability. Okay, this one down here, you can see the average response is actually on the mark, but we do have a lot of spread. So this is small bias, but large variability. So basically on this guy, you just needed to increase your sample size. Okay. Everything else about it was good, and that data is still good data. And this one you can see way off the mark. But not a lot of variability, just a lot of bias. Useless. Data becomes useless when it's biased. Okay, number 8. Get a little room there. True or false? If false, explain why. All right. Interviewing selected people at a local supermarket can be considered an example of random sampling. That would be false, right? People at a local supermarket would not be a representative sample. I guess in theory, if you're only interested in, shopping habits of people at this particular supermarket and the selection process was, random, then it could be okay. But I doubt that that's their goal, so I would go with false on that. All right, next quiz. Choose an SRS of size n from a large population proportion p, having some characteristic of interest. P hat is, of course, the sample. What is the mean of the sampling distribution of p hat? Well, we have a formula for that, right? The mean of p hat will be equal to p. Okay, what is the standard deviation of the sampling distribution? Again, we have a formula for that. Okay, and these are on your formula sheet, the second page. All right, under what conditions can the formula for standard deviation of p hat be reasonably accurate? Okay, so we've talked about this before. Remember, if the sample becomes too large relative to the size of the population, you're not going to see much variation from one sample to the next. And we said the key thing was we needed the population to be at least 10 times the size of the sample. And there you go. The population must be at least 10 times the sample size. Okay, number 4, the sampling distribution of p hat is approximately normal when the sample size is large. Interesting, please don't confuse that with the central limit theorem. That's also dependent on n being large, but we kind of have two different criteria for what's large for n, right? In this case, we're not talking about x bar, we're talking about p hat. So large enough when we're talking about proportions is, remember we learned it in chapter 8, n times p must be at least 10, and n times 1 minus p must be at least 10. If we meet both of those criteria, we can say we have approximate normality. All right, according to government data, 22% of American children under the age of 6 live in households with incomes less than the official poverty level. Okay, so that's a parameter. A study of learning in early childhood chooses an SRS of 300 children. So there's our n. So this is p is 0.22, n is 300. Okay. Now, this is something we could do, in chapter 8 with the binomial distribution, but in chapter 9, we're probably going to do a normal approximation. Sure enough, there it is. All right, so what's the probability that more than 20% of the sample are from poverty households? And again, before you even do the problem, you got to know the answer to this will be more than 50%, because 20% is below the mean, and we're doing from that point to the right forever, a right tail. So we're going to capture more than half. So just a side note, something I always think about before I do the problem so I can catch a mistake if I somehow do the complement by accident. All right, so we want to find the probability that p hat is more than 0.2. All right, now they're basically telling me to use a normal approximation. So let's do our checks to validate our calculation. All right, so the standard deviation formula, there are certainly more than 3,000 children out there in America. So it is safe to use the standard deviation formula. Okay, normality checks. I'm gonna run out of room. 300. 100 times 0.2. Okay, both those counts are at least 10, so we're approximately normal. These are expected counts, expected successes and expected failures. In this case, success would be finding a child living in poverty, but that's what it's kind of defined as. I'm just gonna R at least 10, so we may assume approximate normality. Okay, also, we should mention if the data is good data. In this case, we don't actually have a p-hat. We're asking, could our p-hat, what's the probability of it landing somewhere? So we don't have to talk about, did it come from an SRS or not, which is fun. I always like it when I don't have to do one of the checks. It saves a little space. All right, so let's get our z-score. Okay, so there's our z-score. And now let's get our z-score worked out. Let's see, negative 0.8362. So it gives me a probability of approximately 0.7985. And that's not surprising, as we already knew it was going to be above 50%. So that's in line with what we expected. Of course, we should now write our answer in a complete sentence. Right? The probability that more than 20% of the sample are from poverty is approximately 80%. Again, we could have done this with binomial. If you used binomial, you would have gotten, I believe, about 78%. So again, it's approximately correct. All right, number 6. What's the probability that more than 30% are from poverty? Okay, now we're going to be expecting a smallish answer because 30% is way above the 22%, right? The 20% is below, but now we're going way above the mean, so we're expecting a smallish probability here. All right, same checks apply from above, so I'll just get right into doing the problem. And a z-score. And that should work out to be 3.345 standard deviations above the mean, which is pretty far, giving us a small probability as we already figured. So it looks like it's something like that. So pretty darn rare. And there you go. Again, we should write a complete sentence answer. The probability, now I'll write it, I have some room. I should say the approximate probability, because this did come from a normal approximation. Of obtaining a sample with more than 30% in poverty is, I think it's 3 zeros, or no, is it 4 zeros? Can't read that very well. Yeah, so again, I'll just do it on my calculator, make sure I got that right. CDF, lower bound is 0.3, upper bound is infinity. Mean is 0.22, and standard deviation is 0.3 minus 0.22 divided by point. I better throw a parenthesis there just in case. 0.22 times 0.78. Uh-oh. Yeah, I must have entered something wrong. Okay, so there's the correct, that is the correct z-score. So just confirm that z-score. So that would be my lower bound. Upper bound is infinity. Mean is 0, standard deviation 1. Yeah, okay. There we go. All right, so that was quiz 9.2. Let's take a look at a quiz from our last lesson, 9.3. All right, scores of students on the ACT, blah, 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 normal distribution, mean. Okay, so we have normal, 20.4, 5.8. What is the probability that a randomly chosen student scored 24 or higher? Okay, we're talking about a single student. So in other words, we're saying what's the probability that X is greater than or equal to 24, okay? And this is what we did back in chapter 2. Notice I don't have to do any checks. They already told me it's normal, right? Sample size is 1. I don't have to confirm the use of my standard deviation formula. I get to just use the parameter for standard deviation. So get my z-score. Okay, working that out. Should get 0.62 something or other, and a probability of approximately that. And that should make sense, right? This student is clearly doing better than the average, but not so much better that they've exceeded 1 standard deviation yet. Again, be nice to write this as a complete sentence answer, right? The probability of a randomly selected student earning 24 or higher is approximately there we go. All right, next one. What are the mean and standard deviation of the average ACT score for an SRS of 30? See, notice they even told you, hey, now we're dealing with X bar. We're talking about the average of 30 scores, not one single student's score. Okay, well, the mean of X bar is equal to the mean of the distribution, right? So in this case, it's going to still be 20.4. Okay, and again, I hope that makes sense. What we're saying is sometimes our sample mean will be higher, sometimes it will be lower, but it's going to target the actual mean of the population. Okay, standard deviation of X bar. Okay, and again, these formulas are on your formula sheet, and just to confirm that. Okay. wrong page. See if I can find the correct one. There it is. Sorry, it's on page 2. Okay, so there you go. And again, it's nicely labeled, so it's telling you, hey, when you're dealing with X bar, these are the formulas you're going to use. Okay, we haven't learned this yet. This is when we stop playing make-believe about knowing the parameter for standard deviation. But in this case, knowing the parameter is reasonable because you could have all the data on the ACT if, obviously your company is making the ACT. All right, so our formula. Okay, and that's going to give me 5.8 divided by the square root of 30, whatever that is. Okay. Now, to safely use this, we need at least 300 students taking the ACT, which we clearly have. Okay, so there are at least 100 students taking the ACT. So it is safe to use the standard deviation formula. There we go. Say that over and over again. All right, question 3. What is the probability that the average ACT score of the group of 30 is 24 or higher? Okay. Now this is going to be a much smaller probability than we found for a single student, right? Because now I'm looking at the average of 30, so getting 30 students that are all on average scoring much better than the mean is going to be much less likely. Okay. They told me it's normal, so I don't have to do my normality check, and I'll say right there for my standard deviation check. So let's just get right to it. Oops, n is 30, sorry about that. All right, work out that z-score. Looks like we should get 3.4. And sure enough, that's going to be a pretty low probability. I'll assume the 3.4 is correct. And very small probability. And again, we would write a sentence. The probability that the mean of 30 test takers being 24 or higher is approximately. There we go. All right, last question. Would your answers to 1, 2, or 3 be affected if the distribution of ACT scores in the population was distinctly non-normal? Here's a tip for you. I like to ask questions like this on the test because this is really getting at, do you understand normality and when you have normality and when you don't have normality? So question number 1. We used a z-score, meaning we use something that only works when I have normality. Okay. Well, normality was given, but now they're saying, what if it weren't given? Could I still do this calculation? And the answer to that would be no, right? Because I'm talking about a single student. Okay. But notice questions 2 and 3, I'm now talking about X bar. I'm talking about the mean of a group. And the mean of a group is different, right? The central limit theorem says, as I start looking at the sampling distribution of X bar, it's going to become normal, regardless of the distribution of the actual data, because the distribution of X bar will be normal. So long story short, question number 1 would be affected. Since it deals with a single student, but questions 2 and 3 deal with X bar. Whoops, sorry. Didn't realize I wasn't showing that. And the central limit theorem will give approximate normality. To the sampling distribution of X bar if n is large enough. Okay, again, for now we'll say 30 is large enough. We'll get more into that in a future unit. All right, so there's your quizzes. Hopefully those are all easy and you'll do well on your test.